The Big Bang Theory states the universe started as a singularity. A singularity is the center of a black hole where inside of them, gravity and density become infinite, space-time curves and becomes infinite, and the laws of physics no longer work. About 14 billion years ago, an event inside of the singularity suddenly occurred where all the matter and energy inside of the singularity was sent out in all directions. It inflated, and in the trillionth of a second, the universe went from being subatomic to being the size of a golf ball. The universe continued to expand, and soon the matter clumped together and it formed our galaxies. The universe continues to expand, and our galaxies continue to move farther and farther away from each other. It is believed that the energy that was sent out during the Big Bang was immediately put into a place called the Higgs field. The Higgs field is accompanied by the Higgs boson, which is one of the 17 particles in a model that was created to classify all of the known elementary particles, called the Standard Model. The Higgs boson interacts with other particles and gives them mass in a process called the Higgs effect. Once the universe began to cool down, the particles began to gain mass from this field, and because of this, they began to form composite particles, which led to the creation of atoms. Edwin Hubble was a cosmology expert born November 20th, 1889, and he died September 28th, 1953. He did many things. He discovered that our universe held other galaxies besides the Milky Way galaxy. He also created the Hubble sequence, which is a system of grouping galaxies based on their appearance in photographs. But for this case, the most important thing he did was his work with redshift. Redshift is the way we can tell how far an object is from Earth. You find redshift by measuring the wavelength of the light emitted from the object. If the object has a spectrum shifted towards red, that means the object has longer wavelengths than it did previously, and the object is moving away from Earth. The farther a galaxy is, the faster it moves away from Earth. But how does this prove the Big Bang? This proves the Big Bang because it shows the universe has continued to expand after the Big Bang. But that still doesn't explain what is causing our universe to expand. And we don't know much. We do know what's moving us apart is called dark energy. 73% of our universe is made up of dark energy, and we don't even know what it is. Scientists believe that this energy is a force that opposes gravity. This energy not only expands our galaxy, but the speed at which it's expanding is accelerating. The solar nebula is the rotating cloud of gas, and the planets and sun formed from it. It is also just any nebula that stars and exoplanets can form. The nebular hypothesis is another theory, but this one explains how our solar system formed. It was created by French mathematician Pierre-Simon Marquis de Laplace. The theory states that about 5 billion years ago, the matter in the universe created clouds of gas and dust. One of the clouds had an increase in nearby gravity, likely due to a nearby supernova. This is the solar nebula. Once the center of the nebula was 10 million degrees Celsius, hydrogen fusion began and the sun formed. While this happened in the center, the other planets formed around it. Cosmic inflation is the idea that the universe has not always expanded at the same rate throughout history, and that there have been moments where there have been extreme inflation, where the universe doubles in less than a second. The inflation slows down until the next extreme inflation period. But cosmic inflation goes against the Big Bang Theory, which states that the universe has always been expanding at the same rate. So, which theory is true? It could be either. We still have a lot to learn on cosmology, and there are constantly new advancements being made. For example, Takuya Hashimoto and his colleagues at Osaka Sangyo University in Japan have made some discoveries which suggests that stars had begun forming 250 million years after the Big Bang. This is groundbreaking because it was previously thought that it was impossible for stars to be that old. There you have it, Mr. Winterfield. The Big Bang Theory explained in 5 minutes and 1 second.